So in this section, we'll discuss about sequence diagram. So what is sequence diagram? In the information system, we can draw a sequence diagram to show the object interaction. So there will be some objects, maybe user object or data object, and there will be some interaction arranged in time sequence. Let's say if I want to log in, then when you log in, you need to input ID, password, and then go to the first page, and then you go to some other page. So this kind of sequence can be drawn in the sequence diagram. We call it depicts the objects and classes involved in the scenario and the sequence of messages. Okay, there will be some messages exchanged between the objects needed to carry out the functionality of the scenario. It means every scenario may have different sequence. For example, if I'm a user, maybe the sequence is like this one. But if I'm an administrator, the sequence may be a little bit complex because I have more roles than the users. So these sequence diagrams are widely used by businessmen and software developers to document and understand requirements for new and existing systems. So when you later develop this program, you need to also show this sequence diagram. So in the sequence diagram, there are three components that people already set up. First, we call it actors. So actors mean someone who has the role. So an actor, we call it, this is UML diagram. UML, where I already mentioned this one. It is unified modeling language. So we can have any modeling language. So the modeling language can be about the sequence diagram. It can be also about the system architecture. The modeling language about the ERD and the relationship diagram. So all of those are included in the UML, Unified Modeling Language. So there are many types of the Unified Modeling Language, and one of them is the sequence diagram. And whenever we draw a diagram, we need to know about who is the actor. So the actor in the UML diagram represents a type of role where it interacts with the system and its objects. So the actor, like I mentioned to you, the actor can be user, can be admin, or let's say in the university, you know about the student, or maybe officer, or maybe professor. So the actor can be many kind of roles. Lifeline, we call it, it is a lifeline. It is an element name which depicts an individual participants in the sequence diagram. So, for example, we have this as an object, so we can have this one as lifeline. So basically, each instance is a sequence diagram that is represented by a lifeline. So lifeline elements are located at the top in the sequence diagram. So this is the lifeline. and yeah, we can have this line to indicate whether this object or this element exists or not. And we can put comment. Comment means something about the description. Usually we can show like this rectangle with a folded over corner as shown. So the comment can be linked to the related object with dash line. So we have this dash line to indicate what is the meaning by this object and what are the rules and etc. So this is an example of the sequence diagram. Now if you see this one, we have an actor, which is user, and we have a lifeline, because this is a lifeline. A lifeline always portrays an object internal to the system, whereas actors are used to depict the objects external to the system. For example, there is a user and he wants to buy a theater ticket. This theater ticket is a web system, and then this web will connect to a server. So there will be a kind of communication for the user. He at first will insert the card to the system in the theater, and then the user will select the date. After the system receives the card and after the system receives the date, so it will return the seat information. And then after the user decides, he will submit the order, and the order submission will go to the server. If everything is fine, then the order will be confirmed to the user. So this is one example of the sequence diagram. There will be messages. It means it is a communication between the objects. So if we have one object, we have another object, so we can do a kind of communication. So the messages appear in the sequential order on the lifeline. So this one, we have the lifeline. It means this lifeline, after this line, then finish. After this line, finish. So the lifeline indicates that the process will start from here and end it by here. If you look at these messages, we can have the messages with arrows. Lifeline and messages form the core of the sequence diagram. Sometimes we can say this is a messages because we want to say that the user already insert card, or maybe the system will give information. Please insert your card. Then the user will insert the card to the system. Or sometimes we cannot specify what are the messages. So you can just mention that it is a synchronous message, or sometimes we can just mention it is asynchronous message. There will be self message. There will be another kind of message which is participant creation message, or sometimes the participant want to delete the message, or sometimes there might be kind of response and etc. So it is very flexible. It depends on the system. So in the sequence diagram, there are some kind of definition about the messages. we have synchronous message, asynchronous message, return message. We have participant creation, participant destruction, and reflective message. So let's look one by one. Synchronous message. We call it synchronous message. It is used when the sender waits for the receiver to process the message and return before carrying on with another message. So if you have one message to this object, okay, then there will be a kind of lifeline. So this lifeline is indicated with box. If we already finished with this message, we can give some kind of response. So in this case, we don't have any response, but for this message, this is synchronous message. So the object 1 will send message to object 2 and wait. So the arrowhead used to indicate this type of message is a solid one. Okay, this is solid. So if you can see the arrowhead, so the arrowhead here is solid. So it is a synchronous message. Once we send a message, so we are waiting the second object to give a response. There might be a synchronous message. So it is used when the message caller does not wait for the receiver to process the message and return before sending other messages to other objects within the system. So the arrowhead used to show this type of message is a line arrow like this one. So this is by the definition in the UML. If it is the arrowhead with full like this one, then it is a synchronous message. But if it is only a line arrow like this one, then this is asynchronous message. It means this object just sent a message and this object did not wait the response. The return message means it is to indicate that the message receiver is done processing the message and is returning control over to the message forward. So once the object 1 gives the message, after finishing the process in the object 2, then the object 2 will give response to the object 1. Because this is a return message. Return messages are optional notation for an activation bar that is triggered by a synchronous message always implies a return message. It means we have the bar here. So the bar means there might be some process, and after we do some process, then we will give response. There's another kind of message, we call it participant creation message. So in the participant creation message, objects do not necessarily live for the entire duration of the sequence of events. So if you send a message here into the object 2, so this should be live, or this should do something. But for the participation creation message, we can just send something to the object 3. Okay, just send a message. The objects or participant can be created according to the message that is being sent. If the created participant does something immediately after its creation, so you should add an activation box right below the participation box. So if we need to do something here, then you may need to make a kind of box. Participant destruction message. It means we are going to delete the message. So likewise, participants, when no longer needed, can also be deleted from a sequence diagram. For example, this object one or the user, they try to create an object tree, but after the object is created, after sometimes, the object one wants the object tree destroyed. So it means after some time this object will be deleted. So this is done by adding an X at the end of the lifeline of the set participant. So this object is deleted, this object is deleted. Usually we have this kind of thing when you want to sign up to a website. So you need to verify. You need to be verified as a legal user. After you verify as a legal user, they will destroy the token or they will destroy any information. Okay. So it means this kind of things is the participant construction message or the participant destruction message. There might be reflexive message. When an object sends a message to itself, it is called a reflexive message. So it is indicated with the message arrow that starts and ends at the same lifeline as shown in the example below. So if you start something and then at the end you mention something in yourself, so it is a reflexive message. A sequence diagram, it can be obtained from a class diagram. Okay. What I mentioned before, it was something related to the theater or another object. And the development of this sequence diagram is very diverse. Okay. So one example of the sequence diagram, you can use the class diagram. So if you learn the object-oriented programming in the computer programming, we learn about the class. In Python, we have class. So each class represents an entity. For example, I have the class of student. Class student. Then it means I want to create an entity about student. It can be about student name, student ID, student telephone number, student address, and so on. So inside of this class, there might be some attributes and there might be some functions or methods. For example, we can see ATM. I did not explain the detail about the class diagram, but if you look at this class diagram, the class diagram usually contains three parts. The first part is the class name. Okay, and then the second part here is the data members. And this third part, we call it methods. Okay. The class name is ADM. And then in this ADM, we have the data, which is the ID of the ADM, and then cache. So we have cache here. If you look at this object, it is an object of the class of cache. Then it is another class which is cache. So let me just make it simple, just to look at this ATM. In this ATM, we have a lot of methods: switch on, switch off, get ID, card inserted, read card, and so on. So this is the class of ATM, and those are the methods that might be available in the ATM. And then we have another class which is card reader. And then we have another class which is cashier. So we can make a sequence diagram, something like this. In the card reader, okay, it is an object. So you need to insert the card. When the card is inserted to the ATM, so the ATM will send a message to create a new session. So there will be a new session, like what time is the card is inserted, and then who is the one who has the card, and so on. After the session is created, so there will be an object, a new object on this session. So the ATM will trigger a new object session. So after we have the session, then the session will read the card. When it reads the card, so the card reader, the ATM will try to read the card, and then it returns something about the details of the card, like the card number, the card username, and etc. And then the session will ask the user to include the PIN. Then there will be a method read PIN to get the PIN. So the reader will get the PIN from the user. So the PIN will be inserted into the session. If the PIN is correct, then it will return the message that the PIN is correct. If the PIN is not correct, then it will return a message to get another PIN. So this is time by time, and we call this is the sequence diagram. This is another sequence diagram. If the first sequence diagram, it is based on the class diagram, so you can look at this cut inserted. It is a method. If you look at this read card, this is a method. Okay. Read PIN, this is also a method. Then you can define the message according to the method in your class. The other kind of sequence diagram can be just explaining, okay? Because maybe you don't have details of the class diagram. But usually for the developer, usually when you are a developer, you need to draw something like this. So this will be a very good documentation. This will be a sequence diagram for the businessman. If they want to know what is the system that we can create for the login page, for example. So the actor means the user. So I will have some pages like the registration page, the login page, some kind of validation, error message page, welcome page, user list, user delete, and user modify page. Then at the first time, the user needs to register. So they need to register the name, email, nationality, user ID, password. And then after the user input all those ID, then the registration page can give the message about the registration status. So you don't need to go very detailed like the registration is success, the registration is cancelled, but we just written the registration status. And after we have this registration, then the user can log in. So user ID and password will be inserted. In login page, then it will go to the validation page. We need to verify the login whether the user ID and password match. If it matches, then we go to the welcome page. If not correct, then it goes to the error page. And then the error page will give a message to the user about the login error. In the welcome page, so if it is true, so the session user, it will give a response to the users that your login is success, and you will see something in the welcome page. After you are in the welcome page, okay, if your role is admin, you can see all the user lists. And then you can delete any user ID. You can modify any user ID. So if you do something in this user list related to the user delete and user modify, the result will be delivered to the user. Okay. So this kind of sequence diagram will give understanding to the people who want to use your program. So this is another example. I think we already create the list member last week. Okay? We have the user registration. So for example, we an actor user, they access the list member. In the list member, there are many functions. Let's say in the list member, we can add member. Then in the add member, we input all the data and the validation page will verify the data type. For example, if you need to input email, but the email address do not contain any app, then the data type will be error. So if it is errors, then you go to the error page and then get back to the page of the data member. If the validation is true, then add the user to the list member. If you want to modify, so there is a button modification. Then when you modify, you will get the ID. It will go to the update member page. And then, I missed something. There should be a message here about the validation. So after it validates, if it is true, then it goes back to the modification result to the list member. If it is false, then it goes back to this update member. What about the deletion? So the deletion, when we learn about the member registration, the deletion was in the update member form. So we can delete. If the deletion is correct, then we will delete it. If we cancel, then we return to this update member page. So this will show you the step by step from your phone. Okay. So the rule of thumbs. When we do the sequence diagram, rarely use option. It means we do not use like if. So the condition, yeah, we can just remove. Loops. So for example, we use for loop or something. Yeah, we don't specify any for loop in the sequence diagram. Or maybe some alternative else. Okay, if else. Okay, so we don't do anything that one. So we just click an arrow. So if you use those options or for loops or else and etc., it will construct a complicated diagram, and it make them hard to read or interpret. So the sequence diagram should be very clear to mention the step by step, one by one. And frequently, it is better to create multiple simple diagrams. So if later on, when you do your program, I guess your sequence diagram will be very complex. So if it is very complex, it's better to make it a kind of subsequence. So you don't need to put all in one sequence diagram, but make it multiple simple diagrams. So create a sequence diagram for a use case when it helps clarify and visualize a complex flow. So please remember that the goal of this sequence diagram or the UML is for the communication and understanding. Yeah, when you develop the sequence diagram, you can use any tool. Okay? So there are many open source tools. For example, yeah, I give you this one. Okay, so this is a tool. So you can draw your sequence diagram here. So this is a sequence diagram using a kind of syntax. Okay. So what is the title, and then who are the participants, and then from Alice to Bob, there might be a kind of message. From Alice, from Bob to Alice. So what are the messages, and so on. Okay. Okay, so you can also use other kind of tools. There are so many tools are available for free. Of course, if it is free, there are some limitation on the functions. But I guess it is good enough. Yeah, like the visual paradigm online, you can draw and then you can download it. Okay, so that's about the sequence diagram. Okay. Let's take a break. I will continue after that.